I told you we'd come back to the flat rock section here in the North Country, and we did. Ken Adams has changed quite a bit, though, over the last month or so. Actually, we have Dave Franzi with us. How are you, David?
I'm very well, thanks.
I'm very well, too. I wore my heavy coat because I wasn't quite sure how close to reality the precision weather was for today. But I guess the rain's going to hold off for a little bit anyway.
Looks like
It's going to be an okay day for walking through the woods and checking out things. For the benefit of those viewers who may have missed the last program, shame on you. We had a nice tour up here. We saw some huckleberries, excluding Calvin Castine and myself. But we had a good time. We saw what the ice storm had done in this famous flat rock region of Altona and West Jay-Z. We saw what progress had made toward rehabilitating this area, and that was the ecological point of view, and now we're going to get the geological point of view.
The true skinny on this place.
The true skinny on this place from David. You work at the college.
Yes, I do.
You are a doctor of geology?
Yes. Mm-hmm.
Wow.
How
isn't
about
it?
that?
It's amazing, isn't it, to stand next to famous people? And you told me when we drove up, what day is this, the 17th of October 2000, that I interviewed you on the radio 11 years ago?
11 years ago.
What was that about?
That was about a landslide that happened in Waylandesburg. It was about a 2-acre slide on the Boquet River, just between the village of Boquet and Waylandesburg.
It's amazing. I like to find out a little bit about a lot of things, but I don't know a lot about very many things. When I visited or had some friends and relatives who went to Alaska to live and to work, I thought I'd study a little bit about Alaska, so I read the book Alaska, and I learned more about the geology of Alaska than I ever dreamed I'd know. I haven't read too much about the geology of Clinton County, and especially this flat rock region. This is kind of a unique area in so many respects, David.
Oh yeah, it's from a glacial standpoint, from a glacial geology standpoint, northern New York is sort of pivotal in terms of what's happening to the glacier as it's receding from North America. And this would have been about 12,000 years ago.
That's even before I moved to the North Country. Before we begin talking about that, let's get a little bit of your background, where you're from, where you went to school, and how you ended up here in Plattsburgh, New York.
Okay, well, I'm originally from Connecticut. I grew up in the Berkshires in a town called Goshen. And I went to Eastern Connecticut State College, which is very much like Plattsburgh State University, a small teacher's college that became a 4-year liberal arts college. From there I went to Miami, Ohio, down near Cincinnati, halfway between Cincinnati and Dayton. And from there, that was my master's. Then for my PhD, I went to Syracuse University, and I did some work in the Southwest Adirondacks. When I graduated, I spent 2 years at Lafayette College in Pennsylvania. And when the opportunity presented itself to come back to the North Country and back to the Adirondacks, I jumped at it. And here I am. I've been here since 1985.
How long had you been?
This is your cue to say I don't look that old.
Yeah, you don't. You know, nobody looks very old compared to me. It's kind of too bad. It's a good thing we don't have that split screen they use in the presidential debates to see what reactions. Look at Sam over in the back of the pickup truck laughing at that. You think that's funny? You're going to catch up to me, Sam, one of these days. How long had you been in the North Country before you discovered this unique flat rock region?
Well, I guess I started teaching for the Minor Institute program that we run. We run an applied environmental science program out of the Minor Institute, and probably Ken has mentioned that to you. And they invited me up there in 1990, and it was about that time that I made my first visit to Flat Rock. And it was 2 years later that we actually started to put some instrumentation out here for students to use to study hydrology. And that's one of the things that I want to talk about, is the progress that we've made in sort of developing this very unique area into a teaching laboratory, an outdoor teaching laboratory for students.
It really is, too. And there are a lot of students that come here in the course of a year, and they talk about it, hopefully, when they go back home, wherever they're from. It's amazing up here.
Oh, it makes a lasting impression on the students. And even if there wasn't a dollar's worth of scientific equipment out here, this would still be a fantastic teaching laboratory.
Now, from a geological point of view, why is it different?
Well, it's not really different. I mean, we see things like this in other parts of New York and other parts of glaciated North America. So it's not so much unique in terms of what it is, but it's unique in its scale. I think it's one of only a few of this magnitude, at least in the local region.
Let people know where we are. We're probably standing. Are we standing in West Chazy now or Altona?
We are actually in Altona, and if you would like, we can actually.
Let me get over here on this side of you.
See if we can put this map up somewhere. Maybe I'll change maps here, and we can come around this way.
Okay. All right. Magically, we've moved to the back of the vehicle.
Okay.
Now, what have we got?
This is a map of northeastern New York and northwestern Vermont. You can see the outline of Lake Champlain running right up through here. It's the really light blue. The reason this part of the map isn't colored is I got tired of coloring the map. So
Okay.
what we're looking at here is some interpretations of where the ice was at different times during its retreat in the Champlain Valley. So you'll notice that the red areas here are the flat rocks. These are the Clinton County flat rocks, starting way up here at the Gulf, which is right on the Canadian border. And there's a very large one as you're coming into the Gulf. If you go to the DEC trail, you actually cross over this one. That's called Stafford Rock. The Gadway Pine Barrens up near Cannon's Corners is this one right here. That's on Blackman Rock. This is around Irona, and Altona is right there. And this is where we are right now, right on the southeastern margin of Altona Flat Rock.
And in the background is the famous or infamous $1 million dam that we have showed our viewers several times, not only on this program, but with the late Bob Venn in an interview that Sam and Calvin and Bob did up here when, maybe 1992, 3?
Probably.
A number of years ago. And that the remnants of that dam will probably be here as long after you and I are gone, David.
I would imagine so. It's not going anywhere.
All right. So is that the way it looks now? Is this a view of the area now?
Yeah. Well, the map underneath this is a Mylar overlay here. The map underneath is actually a topographic map of the region, so that's true to scale.
Okay.
And these bare rock areas are what you would see today. If you drove there, you wouldn't actually see a bare parking lot. It would be wooded like these are. Most of these are covered with pine barrens, very similar to the barrens that we see here at Altona.
But it's called a flat rock because it is a flat rock.
It's flat rock, I think, because it's barren and exposed, and in places it's flat. But there's actually quite a bit of relief to this. The highest parts of Altona flat rock, for instance, are up around over 1,000 feet in elevation, and the lower parts, down where we are right now, are probably around 600 feet. So there's a fair amount of relief on here, but the rock itself is horizontally layered. And what that does is it produces large areas of fairly low relief, even though it kind of steps down like a terrace. And so even though there's a lot of relief from the highest parts to the lowest parts, the rock is horizontally bedded, and at least locally it looks pretty flat.
It's amazing. Everybody views everything in life with a different perspective depending on your focus and your education. I see this as a rather beautiful area from a lot of points of view, but only because of the way I've been brought up and lived in my life, and you look at it entirely differently. You
Very
shave.
few people see it the way I do, I'm afraid.
But you shave the layers away in your mind, and you try to go back, way back.
Oh yeah, well right now we're standing on a beach in a glacial lake.
Think about it, folks.
I hear the waves washing up on the shore here.
I can hear the Neanderthals saying, "Kids, it's time for lunch. Get out of the water."
That's right. Well, I don't think you want to be in that water.
No. Okay. So let's talk about it.
Okay. Actually, the story starts about 18,000 years ago. And 18,000 years ago, we in North America were under an enormous ice sheet. And it's oftentimes difficult for people to imagine what this thing looked like. Well, here's a map of northern North America, and here's Greenland over here. And you'll notice that the Great Lakes are right in here. The St. Lawrence River is here, and this is Long Island. So at the height of the last glaciation, at its maximum extent, all of the New England states, most of New York, except for a little tiny little bit right down here in Salamanca, it's down near Elmira, was totally encased in glacial ice. The thickness of this ice sheet, depending on whose model you believe, is anywhere from 3.5 to 4.5 kilometers thick, and that's centered over Hudson Bay. Now
that boggles our modern minds, doesn't it?
It really does. And what's even more amazing is that this is 18,000 years ago. I mean, we're not talking in geological terms. A lot of times we kind of go off scale with time. We talk about billions or millions of years of geological history. This is history that is actually fairly recent. So if you were here standing on this spot 18,000 years ago or 20,000 years ago, in that range, you would have been under at least a kilometer of ice. And we know that because we're pretty confident that the Adirondacks were totally covered. If you go up on Whiteface Mountain, you can see bedrock forms up there that have been sculpted by glacial erosion. So we're pretty sure the Adirondacks were covered with ice. And that would have extended all the way down to Long Island Sound, where parts of Long Island are being built as what we call end moraines. These would have been basically piles of sand and gravel dumped in front of the glacier. And if you look at the ice margin carefully, you'll see it comes across Nantucket and Martha's Vineyard and up through Cape Cod. All these are parts of the deposits that were laid down at the edge of the ice sheet. So that's 18,000 years ago. Now, when the ice started to retreat northward, places like the Adirondacks, high areas like the Adirondacks, started to really influence the way the glacier was flowing. Okay, so they would have been...
It's hard for us to think about glaciers flowing.
Yeah, that's true. Actually, that's part of the definition of a glacier. It's not just a static mound of ice and snow. The ice accumulates in the center of the ice dome, and that causes the ice to deform. Oops, there we go. And it spreads out laterally in all directions. If you could imagine pouring really thick molasses onto a tabletop, it would dome up in the middle a little bit, but then as it reached a certain height, it would start to spread out in all directions. So that's kind of what the glaciers were like.
Wow!
But on a scale of a continental scale, it's amazing to think about it.
It certainly is, and I guess it's important to know that.
Well, yeah, it is, because in order for us to know where we're going, say, with climate change, we have to understand climates in the past, and so that's one of the reasons why we study glacial climates. Another reason to study glaciers in general and the deposits they leave behind is that that's the stuff most of us live every day on. A lot of people's wells are taking water out of glacial sediments. So understanding what those glacial sediments are and what their properties are, it helps us quite a bit.
And this area that we live in is, generally the same as other areas across this northern end of North America?
Yeah, generally the same. The character of the deposits and the nature of the way the glaciers affected an area are going to depend on local relief, whether you're mountainous or lowland area, and it's going to depend to some degree on the local rocks that the glacier's overriding.
The glaciers changed the face of the Earth more than almost any other geological phenomenon.
Well, yeah. Well, you got to remember that even during the height of the last ice age, a relatively small portion of the United States was actually glaciated. So in areas that were glaciated, glaciation is a major erosional process. But in other areas, rivers and shorelines, the longshore currents and things like that sculpt the landscape just as much.
So when we sit in an area in a field with a big bowl in it, we may just stop and sit and think or paint a picture or talk a little bit. But you look around and you say, "Oh, I know how this got here."
Well, and I try to. I try to. I was just telling some of my students, I was explaining some of the glacial history to them yesterday, and they said, "Well, you know, when we graduate, will we be able to do the same kind of stuff?" And I said, "Well, you have to realize that." I don't know if I want to say this on the air, but my bachelor's degree was 1977. And there's been an awful lot of water over the dam between then and now.
Here comes that dam again.
And a lot of it's experiential. I go by, you know, I drive on the same roads every day for 10 years, and all of a sudden one day I'll see something a little bit differently, and I'll have sort of a revelation, and I'll say, "Oh, wow, that's what that is." And it's just a matter of seeing it a little bit differently.
Thank goodness for people like David around to explain things like that to us. Imagine if you had to look at everything just through your own eyes. Now with communications the way they are, we can use a lot of different eyes, including the camera's eyes.
That's right.
It's kind of a neat time we live in.
Well, I think it's nice what you guys do too, because actually what you've done coming back to Flat Rock with a lot of different people is exactly what we're trying to accomplish here with our students. We want students to come here with Ken Adams, we want students to come here with me, and we want them to come with any other professors, and there are several of them now who are doing some work out here. And the whole idea is that as they come back to this unique area, they're seeing it through different sets of eyes many times. I think you're right.
You know, and it also speaks very well for our state university here at Plattsburgh, because there are other campuses and other places, and I really don't want to spend time comparing them, but there's no other Flat Rock. I mean, we are so fortunate to be here and to have this classroom.
This is a fantastic place to teach students. Well, just to give you an example, we have a region that was created by a very unique set of geological circumstances that produced a physical environment that is also very unique. It's very harsh. There's no mineral soil here, so there's very little nutrient for the plants to take up. And it's also, during the summer, very, very dry here. So there's a huge seasonal water shortage on the Flat Rock. So that creates that hydrogeology, if we can call it that, the geology of water, creates a very unique physical environment that affects the ecology. So you have the linkage there between ecology and geology, which is something we try to stress with our students. And if that's not enough, then you have Miner's $1 Million Dam, which is sort of a hydrological experiment. And we can put our students to the task of trying to figure out why the dam failed. And that's what we do in our hydrology classes.
Amazingly, that dam was built almost a century ago, what, 1910?
Between 1910 and 1913. And I did see your interview with Larry Gooley. So I'm going to defer all comments about the construction of the dam to Larry. He did a fantastic job researching the building of the dam and the history of Flat Rock.
But it's pretty amazing to have all of this around it, and to have people like you can come up and fill in the gaps of our in our education. And believe me, there are some rather wide gaps. What do we want to talk about next?
Well, let's talk about how the Flat Rock got created in the first place.
Okay.
So we're going to start with this 18,000 years ago recovered with ice. Now we're going to bring the ice back, and at this time now, the Adirondacks are going to start to be a barrier to the flow. Now, here you have to envision a little bit of New York State geography. And I can do this on a chalkboard. I have a chalkboard in the other room. But if you can imagine a map of New York, and you have Lake Ontario sort of in the north-central, northwestern part of the state, and then you have the Adirondacks and the Champlain Valley over in the northeast. On the south side of the Adirondacks, you have the Mohawk Valley. Now, so the Adirondacks are sort of rimmed by low areas. So the glacier is going to actually feed lobes of ice. It's just like your earlobe, right? It's going to push lobes of ice, and that's what I've diagrammed here with these dashed lines. These are areas where the ice has pushed down farther in the valleys than it has in the uplands. See, the ice margin kind of wraps around the northern end of the Adirondacks. Now, what this does, both Lake Ontario, now remember this is also happening to the west of us here in the Ontario Basin, both Lake Ontario and the Champlain Valley drain north. So what's going to happen when you have a mass of ice plugging up the north end of these valleys is you get lakes forming in front of the ice as it's retreating. So now we're talking about 12,000 years ago when the ice has just retreated into the Plattsburgh area. There's a lobe of ice sitting here impounding a very large glacial lake. Now the only outlet for this lake is south near Glens Falls. So this water has backed up in front of the ice lobe here and is draining south into the Hudson Valley. At the same time, there's an ice lobe in the Ontario Basin, and that's also causing water to back up. And that water is flowing eastward through the Mohawk Valley, and all of this is going out to Long Island Sound. Okay, so you have these two lakes. It turns out Lake Iroquois, which is in the Ontario Basin, is a little bit higher, about 100 feet, between 70 and 100 feet, higher than what the lake we have here in the Champlain Valley, which we call Lake Vermont. And it's going to stay that way because the two lakes are bound, they're separated by the Adirondacks in between them. But when the ice gets all the way north to the Gulf here at Covey Hill, all of a sudden Lake Iroquois finds a way to squirt around. Okay, so it's about 100 feet higher. It's going to squirt around the northern edge of the Adirondacks, and all in one event, it's going to send floodwaters. It's as if a dam that was impounding a lake 100 feet deep let loose all at once, but let loose over the entire Ontario Basin. So the city of Syracuse, for instance, would have been on the shoreline of that lake, practically. And Rochester would have been under hundreds of feet of water.
Oh, sure.
So all of that water, an enormous volume of water, came cascading across that and stripped all of the soil that had been deposited over the flat rocks. Now, when it entered Lake Vermont, what happens at the mouth of rivers today, any sediment that's being carried by the river is going to get dumped at the mouth and form a delta, like the Mississippi Delta. Well, that's exactly what's happening here, right at the southwest margin of Altona Flat Rock, right where we're standing. The floodwaters slowed down when they entered Lake Vermont, and they dumped their load here. And that produced a feature known as Cobblestone Hill. You can see I've highlighted it here. And that was the feature that we drove over from the gate over to here. And Cobblestone Hill is one of the key reasons why Miners Dam failed in the first place.
Ooh.
So all of Miners' troubles probably started with this flood event that deposited Cobblestone Hill, which would have formed one whole side of his reservoir. So on the one end of it, he was probably looking at that as a natural low basin for him to impound water behind. But what you realize is Cobblestone Hill, because of the ferocity of that flood, Cobblestone Hill is made of boulders anywhere from 6 to 8 feet in diameter, and it was
that's
like
a big cobblestone.
And that's all transported by a river.
Sure.
And of course, that was like trying to impound water behind marbles. It just leaked like a sieve.
And he didn't have the science back then to realize that.
Well, I think his engineers probably realized that things were going badly when they first started excavating on the site, and they could see how porous that geological feature was.
Tons and tons of concrete into it. You know?
Oh, I know, and to, at least to some degree that worked because they did operate the dam for a short period of time. So
amazing.
But there were other problems he had, and we'll talk about those too. But all of that relates to this one geological event, and it's really a kind of a neat thing. The major analogy to this, the thing that's similar to this in the U.S., is something called the channeled scablands in eastern Washington and Oregon. And that's a place where another glacial lake called Glacial Lake Missoula suddenly let loose a flood, and that stripped even a larger area than this clean of all of its rock, all of its soil. So, like I said before, it's not a completely unique feature, but at least for our region, the size of it is very unique.
It dawns on me that I should consistently identify the person we're interviewing on this program. I got so fascinated by listening to the story that I realized that people may be finishing their evening meal or their breakfast or whatever they might be doing connected with the time of day when the program is aired. We're in the Altona flat rock region here in Clinton County, interviewing Dr. Dave Franzi, geologist at Plattsburgh State, and getting a little more background into how this area was developed, why it is what it is today, and how much we can learn just by looking around here and looking back through history.
Okay.
We're inside a rather unique log cabin, which Dave tells me dates back to the Fitzpatrick days. It looks like it was built fairly recently. It's been kept up very well. Inside, this is you use this as a classroom from time to time, David.
Yes, we do, and in fact, we're hoping to get a lot more use out of it now. We just got a new solar generator.
I saw the lights come on.
The lights came on.
How do they do that?
Yeah, there's no power up here except for what's being generated by our solar unit that's a couple hundred feet away from here. And so now we have power here. I've brought students out here, and we've had slideshows and things like that out here. So it's hopefully going to get a lot of use in the future.
We brought Sam Castine with us, Calvin's brother, and he asked on the way as we were walking over here from our original interview point about 100 yards away, how does David know what the time element is? How does he know it was 10,000 years ago, 18,000 years ago? There are ways.
There are ways. Probably the most common way is with by dating organic materials with radiocarbon isotopes. And basically, there are a certain percentage of carbon atoms that are generated naturally that are radioactive, and they decay at a rate that we know. So a lot of times when glaciers are advancing, they're advancing over forested areas, and they'll knock over trees or forest beds or peat bogs. And those organic materials will be preserved in between glacial deposits. And what we can do is take samples of those, bring them back to a lab, and because we know how fast those carbon isotopes decay, we can get an age on them. So to date the ice margin down in Long Island, we would need to have some kind of organic material between, sandwiched between glacial sediments. And then we would say if the organics are in there, the carbon has decayed since the time those organics got buried, and we can then date the period between the glaciers.
We've been using carbon dating for a long time. There are some other methods, but carbon dating seems to be used fairly consistently.
Well, carbon dating's good because carbon-14 has a half-life of about 5,500 years. That's very short geologically. So we can use it to date fairly recent geological events. Obviously, if you have something that's a couple 100 million years old, the radioactive carbon will be gone below detectable limits by that time. So it wouldn't be good for, say, coal beds in the Appalachians because they're too old. But it's perfect for glacial sediments, which are fairly recent.
What are you saying? Does that answer your question? I mean, I want to make sure. We got a 10-question quiz after this is over, and there's a saw on the table, and we cut your extremities off if you don't get 8 out of 10. All right, we're in your classroom. It looks a little bit like the steak I cooked out back for my supper last night, but I know it's not. It's a general view of New York State and points north, south, east, and west. What have you drawn here for us?
Well, I felt it's very difficult sometimes to think of the scale of all of this. With geological things, you really need to get a regional perspective on it. So what I've done here is I've drawn the outline of New York. Lake Ontario would be right about in here. This little blip is Syracuse. And just to give you an idea of the geography of the state, here are the the Adirondack Mountains and the Tug Hill Plateau over here forming a high area north of Albany. The Appalachian Plateau is down in here, and the New England uplands, the Green Mountains, are off to our east. And what this does is it creates lowlands all around the Adirondack. So you have the St. Lawrence lowland up here in northern New York and southern Quebec. You have the Mohawk lowland. Lake Oneida is right in here somewhere, but this is the Mohawk lowland here. And the Hudson Champlain lowlands kind of rimming around the Adirondacks. And what I've done is I've just kind of sketched in what the ice would look like. The arrows here are indicating the flow of the glacier. So everything up above this line right here is covered with ice. And because Lake Ontario wants to drain north, that drainage is being blocked up here, that's going to create a large glacial lake, which we call Glacial Lake Iroquois. And the only place the water is going to continue to back up until it finds a place to escape, and that's through the Mohawk Valley over here near Rome. In the Champlain Valley, we have Glacial Lake Vermont, and that's occupying around here. The shoreline of this lake would have been right around 600 feet. And that lake is draining south also, joining the meltwater coming out of this lake, and out they go to Long Island Sound. So this is the setting the stage for the flood. Now, all the glacier has to do is just retreat back a little bit more here, and Lake Iroquois is going to find a lower place to drain, and that's right through the Gulf. And that's what creates the flood. Now, think about this. Have you guys been to the Gulf? I think you guys were there one time.
Calvin has.
Yeah.
I haven't been there.
Okay. Yeah, I thought you guys were up there one time. And at the head of the Gulf is this big horseshoe-shaped kind of an amphitheater carved right into the rock, 120, 30 feet high. And what you have to realize is that Lake Iroquois is hooked up to the whole Great Lakes drainage. So at the time when the Gulf opens up, all of the Great Lakes, the glacial Great Lakes, are draining right through that point. So this is basically carrying the same discharge or equivalent discharge of the Niagara River right through the Gulf. And that's what creates, of course, that waterfall, which actually has the same shape as the Horseshoe Falls at Niagara. So just to give you an idea of the scale of this thing. So all of the Great Lakes drainage at one time is coming right through here.
Wow.
So, yeah, so it's really interesting to think of the magnitude of that. And again, we know that this is about 12,000 years ago. Sam, down in Westport, a little bit after the Waylandsburg landslide, not having anything to do with it though, we found the vertebra of a musk oxen, which is an
on.
Oh yeah.
Whoa!
In a gravel pit just on Route 9N, I think it is, between Westport and Elizabethtown.
Did not know that. That's exciting.
And we dated that at 11,300 years.
Wow.
And that date's maybe a little bit young. It probably should be closer to 12,000, 13,000, but the bone was pretty badly degraded at that point, so we don't trust that date a lot. The major event, of course, is something called the Champlain Sea. And when the ice retreats back even farther now, these lakes are going to continue to grow as the glacier retreats. Well, eventually they're going to open up the mouth of the St. Lawrence River. And then, because the weight of the glacier, this is another thing that's kind of hard to imagine, the weight of the glacier actually pushed the crust of the earth down below sea level. So when the glacier opens up the mouth of the St. Lawrence River, in comes the Atlantic Ocean. And we had the shoreline of that event, that body of water, that saltwater body, that's called the Champlain Sea. The shoreline of that at Plattsburgh's at an elevation of 350 feet above sea level. So Plattsburgh would have been under a couple hundred feet of salt water. And how do we know that that existed? We have gravel pits in the Champlain Valley where you can actually find clamshells, marine clamshells that live today in the Arctic oceans. In Potsdam, Bill Kirchgasser at Potsdam University found a nearly intact beluga whale in mud that was deposited during the Champlain Sea. And these are all dated at about 11,500 to 10,000.
These are exciting discoveries, and I don't know why I don't know about them. But well, that's kind of neat.
There's a Charlotte whale from Charlotte, Vermont. It's at the geology department at the University of Vermont. And there's actually, I'm told, and I don't know this for a fact, but I'm told that there's a harbor seal fossil that was found right in Plattsburgh that's now in the Canadian Museum.
Nope, did not know that either.
Yeah.
That's great. We are getting an education. So I don't know if we'll get credits for it, but
that was only about 10,000 years ago, which is kind of amazing.
Okay, what's the next chapter?
All right, so that's the flood, and I think what we'll do is just to show you some of the evidence. I think what we'll do is we'll go up on Cobblestone Hill, and we'll try to find some beaches that were deposited in this glacial lake, Vermont, and then we'll take a look at what the flood deposits look like.
I love it. Let's do it. Dr. Dave Franzi from Plattsburgh State. See, the thing is, you get in the middle of the woods, and you're with a college professor, highly regarded college professor and geologist in this area. He can tell you any cotton-picking story he wants, and if you don't believe me, he won't show you how to get out of here. We're kidding. Actually, this is not a beluga whale story. This is the real thing, and we're standing on Cobblestone Ridge, right?
We're standing on Cobblestone Hill, yeah, and we're just about at the top of it, and we're standing on a beach. Can you hear the waves?
I can just hear them. Oh, I love it.
Now, what we're going to do is a little exercise I do with my students. We're going to look, you can see the road here has just cut ever so slightly into the bank here. And you're looking at a bunch of the cobbles that make up Cobblestone Hill. And if you notice over here, I'll step over.
Yep.
All of these things are about the size of what a cabbage, or about the size of a softball to about cabbage size. And they're all very well rounded. All right, so this is an indication that these things have been tumbling around over and knocking the corners off, smoothing them up, polishing them in some cases. But the remarkable thing here is the size and the roundness of all of these clasts.
How far would these cobbles have come?
Well, that's another very interesting thing. You know, when we look at a deposit like this, we can tell an awful lot about where it came from and that sort of thing. And if you did a careful study of all of these cobbles, you would find out that they are all Potsdam sandstone, all local rocks. Now the glacier is coming all the way down from Canada, and it's sampling rocks from Hudson Bay to Plattsburgh, New York, and yet here we only see cobbles from the local area. So these cobbles had to have been deposited by those floodwaters, because the flood started in Covey Hill and it ended here, the river that was part of that flood. And the only bedrock type between those 2 points is Potsdam sandstone. So all of that river deposit, that flood deposit, is going to be mostly or almost entirely Potsdam sandstone that was ripped up during the flood event. And then the waves and the currents in Lake Vermont picked up those cobbles and washed them around and produced the deposit that we see here. Now, this is what it looks like on the inside. Well, it's covered over here. And it's too bad we weren't a week or two later when the leaves were off the tree, because what you'd find is that this is a narrow ridge of cobbles that were heaped up here by the waves, kind of like a beach ridge in a modern beach. And you can trace these for about a half a mile into the woods. It's a little difficult now with all the vegetation still in leaf, but you can see these things on aerial photographs as well.
So people have actually been studying the geology of this area long before you got here.
Oh my goodness, yeah, going all the way back to J. Backus Woodworth in 1905. And at that time this was pretty well cut. And there's some beautiful old photographs in some of the old New York State Museum bulletins of Cobblestone Hill at that time.
Oh, really?
Oh, yeah.
That's got to be neat for you.
Well, actually, I think Larry had some during his interview. He showed you a few of those cobblestone pictures.
This is quite an area. So there are millions and millions and millions of these cobbles all through here, but then some pretty good-sized boulders too, right?
Oh, yeah. And what we're going to do right now is we're going to walk, 100 feet up the slope here, and we're going to take a look at what kind of cobbles the flood was depositing and compare them to these.
Before we even start moving up there, tell me, how many periods in history were there like this glacial age? Is this the only one that we know of?
No, in fact, different parts of the continent have been glaciated at different times, and the record in North America extends back to about 3 million years ago of periodic growth of glaciers and shrinkage of glaciers. Now, if you look worldwide, we find evidence of glaciers as old as 2.2 billion years old. So glaciation's been with us almost as long as there's been water, free water on the Earth, because that's ultimately the source of the ice, is the evaporating off the oceans and then getting stored as ice on land.
Now we have computer models that not only, we plug in all the facts that we know about in the past, but then we can project in the future. kind of scare people to death, because in 500,000 years, so, you know.
Well, even sooner than that, one of the models that we use to predict how climate's going to change in the future is by looking at the orbit of the Earth and some of the motions of the Earth in space. And at times when we're closer to the sun, we're going to have warm periods, and times when we're farther away, we have cooler periods. And we find that these fluctuate in a very characteristic way, so we can predict when it's going to happen. And we are sort of in a little interglacial period, and probably have already reached our maximum warm climate and heading back slowly towards another glacial climate. We could be doing this all over again before too long.
Not in our lifetimes.
No, not in our lifetime.
Suffice it to say that this winter is going to be back to normal after we've had a little respite for a few years.
Yeah, that'll be cold enough, I think.
All right, Calvin can walk behind us, and we can talk and walk as we go if you want to. Right over here, David, and just explain what we're going to see now.
Okay, the Cobblestone Hill feature is a very narrow, elongate ridge. It's about 2 miles long, and it's about a half a mile wide at its widest. And it's a couple hundred feet high at its maximum height. And all of this elongate feature was deposited on one side of the delta that flood made when it entered Lake Vermont. So what you have to imagine now is that to the northwest of where we are right now, there's a huge volume of water coming straight at us, and we're right on the shoreline where this stuff the water's gonna start to slow down and dump its load of boulders, and deposit this cobblestone hill. So now, right up ahead here, we'll start to see some of the cobbles that were laid down, and you got to keep in your mind what the beach looked like to be able to compare these. Okay, so if you turn the camera into our right, you'll actually see some rocks that look like they could be bedrock. They could be actually part of the ledge that's in place and never been moved. But these boulders right here are actually stream pebbles, if you will, deposited in that glacier flood. And the one I always point out to my students is that one right now, which is a little over 8 feet long. So if you can imagine the force of water that has to be exerted to move a pebble that big.
You know, I can vouch for the power of water living 18 inches from the Saranac River in Morrisonville.
Okay.
And the high spring floods do manage to roll things around.
Yes.
So I can imagine if you have a torrent, as this must have been.
Yes.
It would. It could really roll those big stones.
Yeah, we really don't have an analogy for this. You know, something that we can.
No, not in modern history.
Not in
for sure.
Nothing we see in the Saranac or the St. Lawrence or the biggest river in the world can't prepare us for the magnitude of the flood that must have existed to produce this deposit.
You know what? You know, the word cataclysm comes to mind when we talk about these kinds of events in history, and there have been some cataclysmic events besides this one in the history of our continent.
Oh yeah.
And it's kind of amazing to see the results of it here. As I said, from Dr. Dave Franzi's perspective, because we might come up here just for a walk in the woods to take a look at Miners Dam and not have any idea how those rocks got there. But that gives us a whole new point of view. I love it.
Well, that's what I enjoy most about the teaching side, is to introduce people to the first time, to give them a slightly different look at things. And yeah, you don't want to drive with me, I'm told, because I'm constantly looking out the window and driving off the road. So,
well, driving off the road may not work too well. But you don't want to ride with me, because I'm constantly trying to pass on information I receive. As I said at the outset of this interview, I don't know very much about any one subject, but I love to learn.
Well, and
since I have such a terrible memory, every day is a learning experience. Oh, those are pants. Very nice. But this is a great experience and a great learning experience for us today, and we appreciate you taking time out of your busy career to come up here. How busy are you this time of year? Just, I don't want to know, do I?
Oh, it's pretty hectic this time of year with a full course schedule and all the committee stuff and research going
on. We could eliminate meetings.
Boy, I'll tell you, if you can find a way to do that, I want to know about it.
There are an awful lot of people in business now saying if we could only eliminate the meetings and I could sit at my desk for an hour and get something done.
Oh, yeah.
Well, that's the age we live in, I guess, you know.
I suppose so.
The more we know, the more we want to know, so we have to pick other people's brains to get there.
I'd much rather do this all day.
Oh, yeah, and so would I. In a heartbeat. What else can we see up here? Anything in this general area?
Well, it's a little bit difficult here because this is pretty much what Cobblestone Hill would have looked like before the dam was built. And we actually get a much better look at the side of the hill where we had the scar pit, where the concrete is poured over the side. So I think what we'll do now is just head over and drive the concrete road.
Let's do that. Yeah, as Dave said, this is a good area to get a panoramic shot of the $1 Million Dam and things connected with it, and a lot of different areas surrounding the Altona Flat Rock region. As we can see, they poured a lot of concrete in here trying to prevent the water from draining out of this area, and it didn't work for very long, but it did work for a while. What a spot, Dave. This is a great spot.
Yeah, this is really nice, and what I was explaining before about getting the students out here and working to investigate why the dam failed, and they can stand at a spot like this, and it's easy for them to imagine what this might have looked like filled with water when they stand here. So it's kind of a nice scale for students to work at. It's large enough that you can keep them busy for a very long time, and it's complex enough that they have some problems that they need to work out. But it's small enough that they can envision what the thing might have looked like.
It's easy for me to envision 90 years ago. It's hard for me to envision 10 or 12,000 years ago with ice as thick as you said it was. It's almost beyond our imagination.
Well, it really is, and that's what I try to stress to my students as well. You know, sometimes you got to just stop listening to the information and just sit back and close your eyes and try to imagine. Like where we're standing right now, we would have been probably right at the water surface of that flood, and Lake Vermont would have been off to our left over here. And if you can just imagine looking straight across here at this elevation, well, that would have been the width of the river at one point. Okay, so you can get students to do that, I think, and if you can bring it down to a scale that they can appreciate it, it helps, I think.
Yeah, talking short sentences for Calvin and me, and thank goodness this is, you know, I worked in the radio business for years. Thank goodness we have some pictures to go along with it, or we spend a lot of time trying to come up with descriptive phrases. And I guess there wouldn't be a much better time of year to do it than right now, with the leaf changes underway.
Well, what's really neat is you can see in the foreground here the cut that was done 2 years ago, right after the ice storm. And right now the heath plants, the huckleberry and blueberry, are this beautiful deep red color. And then if you look towards the upper horizon there, you can see up on the side of the hill.
Toward the right a little bit.
Towards the right, yeah. That was cut a year ago. And then a little bit beyond that, you can't see it from here, but there would have been another large area that was cut just this year. So we have 3 different generations of cutting going on, and you can probably hear the equipment right now.
We heard the equipment in the background. Why the cutting?
Initially, Minor Institute, who we probably haven't given credit to yet, but they own this property, and they allow people like Ken and me to come here very freely and bring our students here. They were very concerned about the fuel loading here. As you know from Ken's interview, that this is a very flammable ecosystem.
Oh, I guess.
Yeah, and it's a fire-dependent ecosystem, so not only is it susceptible, but it encourages wildfires. So after the ice storm, with all of the canopy of the jack pine forest lying on the ground, they were very concerned about the fuel loading. So they undertook the cutting. And since that time, I think it's evolved a little bit. We're using the cuts as not only a management of the Pine Barrens, but also as a teaching tool. So Ken has undertaken some clear cutting, and it's not just Ken, but Herb Boyce, who's the forester that Miner Institute hired to take care of this, and a lot of other people. But we're trying to get the students involved with the restoration of the Pine Barrens.
And we got to see some of the new growth last time, and you know, we look down at our feet and see those beautiful young trees coming up through there, and that's kind of neat to see.
It's very encouraging, isn't it?
Yeah, it really is. It's amazing what progress we've made. Now we're going to take a ride down the old road here, and this road dates back to the time the dam was built, doesn't it?
Yes, it does. And it has about the width of a carriage trail. It wasn't really made for vehicles. But another thing I want you to do while we drive down here is just imagine what this was like for Mike Parsons. Now, Mike owns the drill rig, and he did most of the drilling here when we started our little hydrology project. And Mike deserves a lot of credit because before there was any instrumentation out here, before we had any equipment out here at all, he came out and donated his drill rig to the college for 1 week and came out here and drilled a bunch of wells. And he drove down this road, and his drill rig is 24 feet long, 16 feet high, 8 feet wide, and it weighs over 50 tons. So I want you to imagine that now as we drive down this road, just how much of a chance he took in bringing his livelihood.
That's truly amazing, but it's fairly typical of the way many people, how magnanimous people are here in the North Country and willing to share their expertise and their equipment for a cause. That's, well, you know, it's something you and I may take for granted far too often, but this area, the Altona Flat Rock area and Clinton County are unique in many ways, and people are one of the reasons we are unique.
Well, yeah, and for Mike to do that, not knowing whether or not this project would ever succeed, was really magnanimous, like you said, and more than any one person, he really got the project off the ground. Since that time, we've had a lot of grant money, and we were able to bring him back, and this time we could pay him what he deserved, and he drilled us a bunch more wells just this summer.
All right, we're gonna start on the way, and as you think of things to talk about and what we're looking, just continue the monologue. It's not a dialogue. Anytime you need a breath, I just fill in extraneous words.
Well, yeah, my students will say I never need a breath. So, so we're just driving over the flank of Cobblestone Hill here, and they literally just poured the concrete out. I heard an interview one time on the Flat Rock, and he was saying they built rails out here, and they dumped the rails over and raked all the stuff out by hand, and just went around the boulders that already existed here. So this would be what the wooded area we were just at would have looked like right after it was deposited.
Yeah, young people think we have pretty amazing technology today, but go back 90 years and imagine what this must have been like, just getting the equipment and the people and the animals and whatever it took to get that concrete in here.
Oh, it was amazing. It really was, and to think of the technology that they had at their disposal versus what we have today. It probably would cost 3 times as much or 10 times as much today to build this same structure.
Again, we're interviewing Dr. Dave Franzi, geologist from Plattsburgh State. Spends a lot of time up here in the Altona Flat Rock region of Clinton County, spanning the towns of West Chazy, Altona. Any other towns represented?
No, I don't think so. The Little Chazy River clips part of Beekman Town, but a little bit farther down, so it's not up here. Just coming into view now is the reservoir that is sort of a remnant of what was once Miner's $1 million reservoir. Watch out for the low branches here. And my students have been working now trying to survey in this entire reservoir basin. We're trying to get a very detailed topographic map so that we know the exact shape of the basin and we can calculate what the volume of water would have been. What we're interested in now is how much water is down there right now at the moment, and how much water would have been in here at the time when Miner Miners Dam was filled to capacity. So you might see from time to time some survey markers on the sides of the road, and those are just stuff that my students have placed there for their work.
Yeah, there have been topographic maps of this area for a long time, but you're just fine-tuning now, right?
Very much so, yeah. We're trying to get down to a 1 meter contour interval, so we're looking at some pretty fine detail that you won't be able to pick up.
That's great. But those maps will be teaching tools down the road then.
Well, you know, what we're trying to do, and this is probably a good point to mention this, is we're trying to figure out why Miners Dam failed from a hydrologic viewpoint. And one of the ways you do that is with a budget. And a budget just like you would do with your checking account. You measure all the incomes, all the inflows of water, and you measure all the outflows of water. And the difference would... Oh, yeah, it snuck up on me. The difference would be what's stored in the reservoir. So if you had more inflow than you did outflow, it would have to be that the reservoir was increasing in depth. So that's what we do. In order to estimate whether or not the reservoir is still leaking, we measure how much stream flow is coming in, how much stream flow is going out. We have weather stations that determine how much rainfall we've had and how much evaporation has occurred. And we calculate the changes in storage in the reservoir, and then we determine from that whether or not there's a net gain or loss to groundwater. So we can just use a simple little equation to calculate whether or not the reservoir is still leaking. And what they inevitably find is that it is still leaking, even today.
I saw a mound back there. Would that be, that wouldn't be a beaver mound, would it?
That's a beaver lodge, yeah. Beaver lodge. And that one's been here for quite a year.
I should have mentioned it as we were going around the corner, but I spotted it out of the corner of my eye. I imagine the fauna is a little bit active up here, especially the beavers and various other creatures.
When we get up to the upper dam, I'll tell you my coyote story.
Oh, really?
Just a few days ago, we were up here. There's something running right down there at the edge of the reservoir.
On the left, on the edge of the reservoir.
It's right at the edge of that meadow. It was big enough, it was probably a deer. But that meadow you're looking at right there is all floating mat. That's all floating sedge. Yeah. So we were out there, we surveyed the entire basin down there, and fell through that mat several times in the process. Oh yeah, oh yeah. I had a group of students. We got some funding from the National Science Foundation to bring students out here to do research. Oh, there he goes. You just catch that white tail bounding across there. A couple of them.
Way back in the woods. I see two of them. Yep.
And so we had 18 students here this summer doing research on the ecology and on the hydrogeology of this area. So it was a very busy summer for us.
I can't imagine what that would have been bringing that drill rig back here. This is amazing.
Yes, we questioned Mike several times whether he wanted to continue, and he assured us he could do it. And thank goodness he did.
What are you looking at, Calvin? Oh, sure.
Oh, yes. This goes on for a mile. And what you're looking at right down here, there's a little moat with a ridge of debris right down here at the bottom of the hill. That is, in engineering terms, what they'd call a grout curtain trench or a slurry trench wall. They excavated all the way down to bedrock, solid bedrock, and they poured a vertical wall of grouting of concrete all the way down to the bedrock to try to seal off the bottom of Cobblestone Hill. So the question I ask my students, of course, is if you went to all the trouble to grout this, and yet when you do the budget on this, it comes up with saying that the reservoir is still leaking, well, now you have to find out some other way for the reservoir to leak. And when we get to the upper reservoir, I'll show you some of my wells, and we'll talk about what that might be as well. So he actually had a couple of problems. It wasn't just Cobblestone Hill. It turns out that he had 2 or 3 major problems with the site that ended up killing the project.
But he wanted it to be here so desperately. The man was passionate about getting it here, and sometimes that clouds our view. Well, because you said he probably had some pretty good information.
But I imagine you don't get to be as wealthy as he was without taking chances. And
When we say $1 million dam, we're not kidding. I have no idea what it would cost to put together such a behemoth in 2000, but it would be considerably more.
I wouldn't even want to guess. That's I'm not very good with money, as my wife will attest to.
My wife too. They should get together. What are we going to do with these guys? I've never been up here this far. This is really neat.
Yeah, and what you'll notice now is some of the larger boulders that are flat. And a lot of these are kind of tabular shaped. You know, they have broad, flat surfaces to them. And one of the things that I'm going to point out, we'll stop here at the weather station. Just pull up another, there's a little turnaround up here. A lot of these big flat boulders are all inclined in the same direction. And in geology, we call that imbrication. If you go to a gravelly river that has a lot of flat pebbles in it, a lot of times the pebbles are all oriented the same way because they line up in the direction of least friction to the flow of the water. And you can actually see the bigger boulders here are imbricated in the direction of that flood. So it's kind of neat. You can actually see where the current used to go. So we'll take a look at that.
That's kind of amazing. And to see that some of them are shaped like tablets.
Yeah.
I didn't see a man with a long beard trying to decipher anything. So, but there are things written in the cement. That was what fascinated me last time we were here. We saw those ancient footprints, ancient to us today because they were put in there 90 years ago.
That's
and
right.
People wrote their names and dates. And so we have a chronicle not only of geology, but people leaving their personal marks here too.
Oh yeah, yeah, and the footprints too are all over the place, especially here. But the tabular shape, the flat shape of these boulders, probably comes from the fact that the Potsdam sandstone is horizontally layered, and so they break off these big flat chunks. And that's how they get transported.
You know, something we can talk about a little bit, various consistencies of rock and stone, and some of it's fairly unique to this part of the world. The Potsdam sandstone is world famous, the name itself, but explain why we call it that.
Well, every time we name a geological formation, we name it for the region in which that particular type of rock is well displayed, and that happens to be Potsdam, New York. Yeah. So, and the Potsdam sandstone is an important unit, an important bedrock formation for the North Country, and a lot of the people who have drilled wells in the North Country, especially in northern Clinton and Franklin counties, are pulling water out of the Potsdam sandstone. So you're pulling it from the fractures, and that's one of the other things we're studying here with the wells that Mike Parson drilled for us, is looking at the groundwater geology as well.
We did a show a couple years ago at the Plattsburgh Quarries, and we got another point of view as they described the various kinds of stone that they were bringing up for use, for industrial and commercial use around the North Country. Yeah,
and there's a quarry just over the border, the Ducharme quarry in Hemmingford, or Havelock, I think they're in. But they also quarry the Potsdam sandstone there.
That's neat.
Yeah.
What have we got? I see some towers and things, and we'll jump off the truck and take a walk down there and take a look at them in just a moment. We've walked a little ways off the cement road, and David talked about the tabular shapes of the stone and which way they were slanting, and this gives you a perfect view of one right here.
Yeah, this is a boulder, about 4 feet long, and we don't know exactly what the dimension is going under the concrete here, but this is a fairly characteristic of the way that flat rocks orient themselves in a large flow of water. They're going to kind of dip upstream a little bit, so this flat shape would offer the least resistance to the flow of water, and in this case the water would have been flowing in that direction. So the dip is toward me, and the flow would have been straight in front of me.
We've come quite a long way since we parked the truck the last time we were sitting there. Just to give an idea, to our viewers how much concrete was poured in there. And they weren't in here moving these boulders around. They were just pouring in and around and over top of them, weren't they?
That's right. That's right. And especially the larger boulders are pretty much in place. And as you pan around, you'll see a number of the bigger ones have all the same inclination. And if you go into the woods where there's no concrete, the boulders in the woods are inclined in the same direction. And that, by the way, is one of the reasons they suspect, if you remember when the Martian lander, when they landed finally and got some images back, they said it looked like they were in a stream channel. And one of the lines of evidence that they used was the slanting of the boulders.
It must drive you crazy when you see those pictures from other planets, huh?
I'm having a hard enough time with Altona flat rock. I don't need to buy more.
It's fascinating for me, I know, to look at them. All right.
It is pretty interesting.
We can walk and talk, David.
Okay, don't get your cable hooked.
I got it.
And we're gonna. Yeah, there's a little bit. In fact, what you'll find is that a lot of times the vegetation grows on the what they call cold joints. These are joints between different pores of concrete.
Yep.
And those are the places where the concrete weathers the first, earliest. So they get a little soil developed in there. So, and all of these rocks are all Potsdam sandstone. Almost a couple of times my students will find something that's not a Potsdam sandstone, but by and large every rock here is the same type of rock.
And it's not too dense? The Potsdam sandstone, how dense is it compared to other rock?
Well, the Potsdam in places can be good and hard. I mean, it's used as a building stone, and it's pretty well cemented together. The thing that makes it erodible are all the fractures that run through it, and that helps break it up into smaller pieces that something like the flood could quarry out. This here, let's just loosen that up a little bit. This is a rain gauge. And this is what they call a tipping bucket rain gauge. And this is, remember we said we were going to do a budget here. So we want to measure how much water is coming in from rainfall. And this is one of the devices that'll do that. Basically what happens here is the funnel has a little drip mechanism in it. And that sets the drip right on top of this cup. And that cup is on a rocker. And what will happen is when that cup fills up, it'll cause this thing to tip. And when it tips, this will make a magnetic contact in here, and that'll record on this little data logger. So I'd take my computer and I hook it up to the data logger and download. So every time that thing flips, it'll present the other cup to the drip, and then it flips back the other way. So it just keeps rocking back and forth, and it takes 1/100th of an inch of rainfall to fill up the cup. So every time that thing flips, we've had 1/100th of an inch of rain.
So we didn't get much precipitation yesterday, but maybe enough. In some areas we got a little tiny. 1/100th isn't a heck of a lot.
No, it's not. It's not a lot of rain. So yeah, it doesn't take an awful lot to get that thing to
But you
flip
can,
over.
over a year or 2 or 5 years, you can develop patterns. How long has this been here, Dave?
This has been here since 1996.
For 4 years, you can get some pretty good stuff over a 4-year period. That's great.
There's also a nice weather station at the Minor Institute that has a record that goes back to the 60s as well. And all that, you can get all that information from the Northeast Regional Climate Center. So you can get on their website and download that information. I think they charge a nominal fee. I'll find out pretty soon because I have to go back to them pretty soon. I have to get some of that data for a student who's working on another project. But yeah, we're hoping to get a really long-term record of stream flow and rainfall here, and people can use this for whatever purpose they want.
And you don't have to come and download every day, do you?
Oh no, the data loggers that we have here, by and large, every couple of months, really. It's mostly the battery power that you have to worry about. And one of the things that I want to do today before I leave the site is change the batteries in all my stream gauges. So,
how many do you have?
Well, we have 3 that are operating right now. One is in the reservoir, measuring the height of the water.
Right.
Okay. One is at the outflow, where we were a little bit earlier today, and we'll go back to that one. And then there's another one over here at the where the Little Chazy River comes into the upper part of the reservoir. So the two stream gauges at the outflow and the inflow are measuring stream water coming in and going out. The one that's recording the reservoir level is measuring the amount of storage. So again, that all goes into us being able to do a budget.
And do you have programs that you've designed that can look at this data and come up with some various conclusions, or do you have to analyze all the data yourself? Or
oh no, I don't do that. I make my students do it.
Oh, cool. But have you designed special programs for that purpose?
Well, there are software packages that are available to do that kind of stuff, but when I teach, I like to use I like the students to set up the problem themselves, and we just use microcomputer spreadsheets for the most part, and they can do a lot of this budgeting. It's just simple algebra, this plus this minus this and that, and they can come up with the.
Geologists have to look in the past as well as into the future, and I'm just wondering, since you've been coming up here, especially since you've been gathering this data, have there been any big surprises?
Well, we've had a couple of really wet years. And we've had a couple of really dry years, and it seems that during those years of extremes that I tend to learn more about the way the place works. Like just this summer, for instance, when we were mapping the reservoir basin here, that area where I pointed out the grass mat, there's a bunch of groundwater seeps that come out at the other end of that embayment there, the end of that meadow where the deer were. And we hadn't actually seen those seeps during other summer research experiences because it's been too dry. But it was a fairly wet year this year, and those springs were active well into the summer, so we got a good look at them. And when we drilled some wells on the other side of the reservoir, we think we have a good understanding of how those springs work. So
it's getting so we don't know what an average year is like up here.
It's been right, and that's the thing too. In terms of what is average here, we wouldn't be able to tell you because we've only been here for a handful of years. But as time goes on, we'll get a better feel for it.
That's terrific. Where are we going next?
Well, we'll continue on down. We'll go to the upper dam. And maybe before we go, I'll just point out here the weather station. Some of the other things that we have to measure to do this are the wind speed and wind direction. You can see the anemometer up there on top. The silver device up there is measuring relative humidity, and the brass colored one is measuring air temperature. And this other little thing way down the bottom is measuring solar radiation. And then all of that's powered by battery power, which is supplemented by the solar cell.
I've always been fascinated by watching weather, and I don't know a great deal about it. And in recent years, it's been possible on an economical basis for individuals to purchase little weather stations. You'll see them perched on private homes all over the place. And one of the great Christmas presents my wife bought me a few years back was a little tiny weather station, relatively inexpensive, that measures the basic things. And we live in a very interesting little hollow right down there in Morrisonville. Mm-hmm. And so when you see winds over 40 miles an hour consistently, you got problems. But it is very interesting to do that. And all these little weather stations can be connected with computers that record data over a long period of time. So we have amateur meteorologists springing up all over the place.
And that's a great thing.
And it is a good thing.
And kids in school can develop their own little network of weather stations and bring that into their classes. I think it's a great thing.
And it's a good point well taken here, because it connects us with our environment. Some people are just content to, just walk along the road, and if it's raining, they'll get out of the rain. And other people are not content unless they know why it's raining, and did it rain yesterday, and will it rain tomorrow. When we get connected with our environment, I think life is a lot more satisfying, and nobody could speak to that better than you can, because you've been connected with it for a long time.
Well, it's a lot more interesting anyway. It does make life a a lot more interesting.
All right, let's move along. We're talking with Dr. Dave Franzi from Plattsburgh State, talking about the geology and a lot of other topics connected with the Flat Rock region in West Chazy and Altona. And we're on the move again. We were just discussing what a great day it is. I mean, it's a perfect day to be out here. Not much wind, 5 to 10 miles an hour maximum, and a low right now temperature. What did we say? About 52 degrees.
Just about 52 degrees, yeah.
So this is a nice day for a ride in the woods.
A beautiful fall day. I think the colors this year have been better than I've seen them in 3 or 4 years.
Yeah, sometimes they're kind of dull, and it depends on how high above sea level you are and where and what areas you are. Well, we get kind of a very interesting cross section up here. I just wrote a newspaper column about living in an area where you have distinct seasons, and the older I get, the more I gripe when it gets really, really cold or the snow gets too deep to walk in. But I don't think I would be happy anyplace else.
Oh, I don't think so either. I don't take heat well, so this is a great...
Oh, you don't?
No, well, I'm a glacial geologist, remember.
Well, that makes sense.
No, I like the cool weather, and I think the fall is my favorite time of year, especially in a place like this. Now, if you pan down the road in front of us, you can imagine Mike Parson with his drill rig.
No, yeah, I can. Every time the wheel rolls, I can imagine I'm trying to drive that big rig down here.
And a lot of this has dropped down back over the road since the ice storm. But we had Lauren Parker, who lives down the road a little bit, came up here and built a 2x4 template of what Parsons' rig would be, and he drove it down here so that he would know where to cut the branches.
No kidding.
Yeah.
That's pretty clever. It's the least we could do.
Well,
great.
He's done a lot of work for us in the past. Lauren's been a good friend to the effort here.
I asked Ken Adams the last time we were here whether he stays in touch with many of his former students, but when you instill that passion for the subject matter in these students, once in a while you like to keep track of them, and are any of them teaching now, do you know?
Well, as a matter of fact, a fella who came here as an exchange student from University of East Anglia, he spent 1 year here and did a project with me up on Giant Mountain. We did a glacial geology project up there. He's now teaching at Cortland State University.
That makes you feel good.
That makes me feel really good. I take full credit for him, too.
Of course you would.
Every chance I get. But he's been working in places like Alaska and Antarctica, and so he's actually outshined his, at least this former teacher.
You know what I mentioned earlier in the program about reading the book called Alaska? My grandson, Frank Wright, got a geology degree from Potsdam State and went to Alaska, and for a year or so he unloaded trucks at airports and plowed snow, and finally he walked into a company one day and said, "Hey, I'm looking for a job." And the secretary said, "Where did you graduate?" He said, "Oh, Potsdam State in northern New York," and a voice from the back of the room said, "Potsdam, get your butt in here, I want to talk to you." And the guy was from this area. Long story made short, he hired him on the spot, and he worked on the north slopes up there.
Woodpecker.
Yeah, Woodpecker. Off Prudhoe Bay up there. And,
oh, yeah.
In the cold country for 3 years before he decided, okay, I'll come back home. But that's interesting.
Yeah, well, and actually the market in geology right now is very, very good, because geologists have traditionally been in the minerals industry or in the oil industry, and now they're very strongly in the environmental industry. A lot of environmental problems have geological roots to them, this dam not withstanding.
Yeah.
So anyway, we're passing right now. This is the upper part of the impoundment behind Miners Dam, and this is a really good place to get a close look at the Potsdam sandstone. You can see the horizontal layering to it. And if you look across there, you'll notice that it kind of rises in steps. The rock comes up, then there's a sudden drop down, and then it flattens out, and then it drops down again, almost like a staircase. And we were talking about that before a little bit, and that turns out to be a really important part of the hydrogeology, the water the study of the water in the ground. That is only becoming now more obvious to us as we have gotten more wells out here and started to really look closely at it. But those horizontal bedding planes that you see there, those fractures that run horizontally, are probably the major carriers of water. So what you want to do when you're drilling, of course, is make sure you intersect a lot of those fractures with your well, and that's usually what's supplying most of the water to your well, are those horizontal ones.
Now, what again is the purpose of these wells? How many do you have?
There are a total of 16 on the site, and the idea is that we want to measure the water levels to get an idea of what the distribution of water pressure is in the subsurface. And when we can do that, we can kind of map out where groundwater is flowing. And
that's what hydrology is all about. Huh?
That's what it's all about. We can determine not only where it's flowing, but what the volume, what the discharge is. So
there's I see some other beaver.
Another lodge there.
Beaver
yeah.
lodges along the way.
Yeah. At times, that meadow there, which is also mostly floating, has been totally flooded with water. Right now, it looks like a lot of it's emergent. It's out of the water, but in the past, that's been almost completely underwater with beaver dams.
Now, during the course of the fall semester, how often do you bring people up here?
Almost on a weekly basis.
Okay.
Oh yeah, well, one of my classes is completely revolves around this site. Now, the interesting thing here, you'll notice we've been in sort of a mixed hardwood and white pine forest. We're going to turn off Cobblestone Hill now and drive back onto the flat rock. And the thing you want to take note of is just how quickly the vegetation changes. You can see the rock outcrops right here.
On the right-hand side.
Yeah, we've only driven, a couple tens of feet into the off the Cobblestone Hill. And we get right now on flat rock, and the vegetation changes right back to pine barrens.
That's amazing.
It really is. And when you look at aerial photographs, the margin of the flat rock is just really clear because the vegetation changes so abruptly. And it's some nice photos on my website that show some of the vegetation patterns on different parts of flat rock.
Satellite pictures, huh?
No, just from a plane. Yeah, we just rented a local plane and flew around and took some shots from. We also have satellite images, and we have high altitude aerial photos that are taken by the U.S. Geological Survey. But no, sometimes just going up in a little Cessna or something is just as instructive. So. Now, we have some wells all around this area, and the closest wells, the water level inside the well is 24 to 30 feet below the land surface, and yet right here we have a little wetland perched right on top of the rock surface. And what that's telling you is just how non-porous these rocks are, at least at this locality. That basically rainwater fills up this little depression here, and it doesn't seep into the ground very fast, so it stays up here. This is almost perennial, this one.
It's really interesting. A lot of blueberry bushes, a lot of huckleberry bushes.
We always make sure we're doing field work in late July. We try to come up here as often as possible.
When we talked to Ken, we mentioned the scope of the Altona flat rock region, and you've shown us a representative drawing on a map. But do you have any idea how many square acres?
Acres, no.
Square miles?
Well, I can do it in square kilometers.
That's good.
The irony is that I still think in English units, but when we write papers, we have to write in metric units because that's the scientific scales that you use are all metric.
Boy.
Yeah, this is. I'm sorry. We're driving through a part of the jack pine barrens that was severely damaged by the ice storm, but not logged. Okay, so this is what it looked like pretty much right after the ice storm happened.
Wow.
And you can see most of the trees snapped in two.
Amazing.
There's very few of them toppled over, which is kind of interesting because their roots just spread out on top of the rock surface. So they're very shallow rooted, but they snapped much more than they toppled. And it had probably, who knows what it had to do with. Ken's probably the better one to talk to you about it. But it's just amazing how much damage there was in this part of the barren.
The color this time of year. Okay, let's get back to the square kilometers.
Okay, the length of that flood river is about 30 kilometers from Covey Hill all the way down to Altona, and it's about 5 kilometers wide. So that in broad terms, and not all of that is bare rock, but a large portion of it is. So it's a pretty extensive area.
What's this?
That's an evaporation pan. Okay. And what we try to do here, it's not operating right now, but we would fill that up with water and just let it evaporate. And we very carefully monitor the water surface in there. And then we can relate that to the atmospheric, the temperature and the relative humidity and things like that, and try to estimate how much water is evaporating from the whole area. You want to keep going? How daring are you?
I've been down there before.
Okay.
I think we walked it.
Go. Where are we going now?
Well, we're gonna travel on to the upper dam, and as we do that, we're descending right now into a little valley that has a beautiful wetland off to the right of the car. This is, in ecological terms, we'd call this a fen. And most of it's floating mat. You can see there's a lot of leather leaf in there, and some cotton grass is in bloom right now. And this thing right now is being dammed up by a little tiny beaver dam, which is right there.
Right there, I see it.
And there's his little lodge right back in there. And we actually have a new wetlands ecologist at Plattsburgh State who's very interested in doing some work on wetlands like this. So we're hoping to get her out here and get her involved in all this work we're doing. But so we're back on the flat rock, and you'll still notice here off to the right of the car some of the wells that Mike Parson drilled for us. These are wells from 1992.
What are we talking about? 6 inches in diameter, maybe?
6-inch well, and they're variable depth. Some are as shallow as 30, 35 feet, and some are up to 80 or 90 feet. The deepest ones that we drilled this year are 130 feet, but they're on the other side of the dam.
130 feet?
Sure. Oh yeah.
Wow.
Well, and actually, since the time we drilled those, I managed to get a crew of U.S. Geological Survey geologists up here, and they came in and put a lot of geophysical instruments down the holes to monitor where the fractures were and how much flow was coming out of different zones. And they were encouraging me to come back out here and drill some real deep wells, like several hundred feet deep, so that we could get some nice information about the Potsdam that way.
Are these some of your dreams? We haven't asked you what you hope to accomplish here in the future. Obviously, your career at Plattsburgh will last another 40 years or so. What would you like to see accomplished out here?
Well, my dream for Flat Rock has always been to develop it for student research and for teaching a lot of different classes, and I think we're well on our way to accomplishing that goal. And as far as what comes out of here, I can see a lot of good student research papers being published that deal with hydrogeology, that deal with the glacial history, that deal with the ecology of the Pine Barrens. The more things that students do and get recognized for, the happier I'll be.
So quite a bit of stuff has been published already?
Well, it's been published in local literature. For instance, just last year we had an NEIGC conference out here, and they published a field trip guidebook for us, and that's the New England Intercollegiate Geological Conference. It's a field conference, and so we've gotten the story out in a couple of different forms, but we can stop here. But what we want to do is get it into some real more traditional geological literature, some of the more typical periodicals. And
Have you done any publishing? Any any writing yourself? You have to write some stuff.
Oh yeah, well it's part of the job, but yeah, we try to get out as much as we can, as often as we can. The problem is that a lot of work like this requires an awful lot of field work for one real paper, so it takes a while. You got to be patient, but you pick away at it from.
And you must be listed on the Plattsburgh State website.
Oh yeah, you can if you go to the Plattsburgh website now, you go to the faculty web pages, and you can find my name there and click on it. And I actually have a web page that's dedicated to what we call the Ecosystem Studies Field Lab, which is where you are right now. And I have some images of the flat rocks and students doing work out here, and a lot of my web pages for my classes also have pictures of flat rock in them.
Just for the benefit of those people who are interested in finding things on the internet, I was approached by a local doctor who said his grandson was going to write a high school paper on the Flat Rock region, and he tried every search engine he could find, and he couldn't find flat rock. Oh. But he just didn't get directed in the right direction, did he?
Yeah, you have to have the right keywords. I don't know. If I don't think flat rock would net you anything. I think I did it once, and I got Flat Rock, Michigan, which I think
oh, you did.
It probably has a Chrysler plant or something like that in it. But no, I think you just need to get the right keywords. And if there's any
famous but not that famous, is that what you're saying?
It's locally famous, yeah. So.
But actually, people in your business know about the Flat Rock region, even people who haven't been here, because we've had visitors from prestigious colleges and universities from around the globe visit us from time to time, and every now and again they come here specifically to see the Flat Rock region.
Well, sure. Last year at that NEIGC conference, I had as many as 40 or 50 scientists from around New England come here and see what we're up to and what we're doing. So I think at least regionally we're pretty well known at this point. And I've delivered papers at professional meetings where I've talked about flat rock. So.
I delivered papers once too, but it was a whole different ball game. Are we going to walk, or what are we going to do?
Well, there's a little lean-to here by the dam, and I guess I should point out this is what is locally known as Skeleton Dam, and presumably this dam was built to serve as a storage reservoir. I guess when the engineers figured out they were in trouble with the lower dam, they decided to start building this one. And this would have served as a storage reservoir that they would have released water from and sent it down to the lower reservoir so that they could keep generating power for a longer period of time. So basically this one was abandoned before it was finished, primarily because they abandoned the downstream project. And there was...
All right, we're going to stick a new battery in and take a little walk and check out the lean-to.
Very good.
All right, we've stopped near the end of the Skeleton Dam, and we're actually going to look down into one of those wells, and I can see the surface of the water, which you say is how far down?
About 23, 24 feet, probably, at this time of the year. And as I was mentioning before, you asked me how we use the wells. Basically, what we would do is we know the exact locations of all these wells, and we know the level of the water in each one of them. And we can map out the water table this way. And by mapping out the water table, we can determine which direction the water is flowing. Now, presently, if you can just take a look through the trees here, you can see the reservoir that exists behind the Skeleton Dam right now. And that water surface is about anywhere from 6 to 10 feet higher than the water level in this well. Oh. And what that indicates is that water is moving from the reservoir toward us. It's moving underground roughly in this direction here. And whereas the surface water is moving out of the reservoir, the outflow is going in a totally different direction. Now, what's important about that is, remember I was saying that the reservoir behind Minor Dam is still leaking. And when I ask my students why, they all say, well, it was leaking through Cobblestone Hill, which is the logical answer to give. But Minor poured tons and tons of concrete over that. And presumably that grouting effort would have stop the flow of water under Cobblestone Hill. So I asked them, is there another explanation? Is there another way that water could be leaking? And here, at this location, we don't have any cobblestone here. This is just flat rock, and we have a reservoir that we know from the way the groundwater table is leaking. So this reservoir is leaking through the bedrock. So not only did he have leaky cobblestone, but he also had leaky bedrock. And that was another major reason why the dam failed. So whereas he grouted one side of the reservoir, he couldn't grout the whole thing, I guess, and so he still would have had a good amount of leakage. The other thing that they would note is that when they look at the stream flow right now, there's probably less than 1 or 2 cubic feet per second moving in the well, in the streams. So the stream flow right now is also very, very low and probably not very conducive to generating hydroelectric power. So he had 3 good strikes against him when he built the dam here.
Yeah, he'd probably come back today and say, David, where were you when I needed you?
Well,
but I'm sure it didn't make him go broke, even though he spent a lot of money. All right, let's walk down here toward the lean-to, and as Calvin catches up to us here as we go, watch the sharp rocks here, Calvin. Boy, every view is nicer than the last one. This is really pretty neat.
The pile of rubble here is man-made. They were going to take that wall, this wall in back of us, and they keyed it right into the bedrock outcrop over there. You can actually see where they blasted a little keyway in there. And those sharp rocks that we walked over were cemented in place, and that would have prevented the wall from kicking out. They actually used the local rocks to and some iron rebar to hold the bottom of the wall in place. So,
interesting.
but this is the trench that would have served as the foundation for that wall if they had completed it. And here we are in Larry's book. This is called Chasm Lake. And you can see the cliffs over there, some nice exposures of the Potsdam sandstone. You can walk over that way. And I told you I'd tell you my coyote story here.
Yeah, that's a good place for it.
Today is, let's see, last Tuesday I had a graduate student from the University of Vermont here. And we were looking at this meadow right across the lake from us. And we saw a deer moving very quickly through that meadow, and sort of looked a little anxious. She was moving really fast, much faster than you would just casually, go through a meadow if you were a deer. And then behind her, just fast as a lightning bolt, there was a dark object right about at ground level, just streaking towards her. And it turned out that she was being chased by a coyote, and she jumped in the water over there and started swimming across the lake, and the coyote was joined by a little pup afterwards. Came up right behind her, and they just sat and watched her swim across the lake. Oh boy. Well, I don't think she looks very happy.
Ooh. That's amazing. I don't know if she's alive or not, is she?
No, I don't think so.
Probably not. No, I don't. I really don't think so. See?
Dead duck.
That's a dead duck. Yep. You see so many Canadian geese are coming in. This is the time of the year. We don't see too many Canadian geese up here, though, do we? Or do we?
Normally, I'm kind of surprised today that they're not out here.
Really?
There's
I know there's a lot of them right nearby, up around Lake Alice. And in 3 or 4 different places, both here in Vermont. This time of year is just amazing from now until the end of the month. Oh. I'm overwhelmed by the experience every year. That's what I mean about coming back to this region a couple of times a year in the spring and the fall to watch those migrations, because they are incredible. And those big, beautiful white Canadian geese come down through. That's pretty neat, huh?
Yeah, and usually they're thick as a blanket on the water here. It is surprising they're not here today.
But this area is is pretty pristine, really. You know, there isn't much going around here. We can't even hear the loggers where we are right now.
It's really funny. Sometimes I'm here and I can hear the cars on Military Turnpike.
Come on.
Oh yeah, yeah. And then other times I come here and I can't hear anything. So it must have to do with the atmospheric conditions or something, that sound travels better on certain days. And but sometimes it's downright noisy here, and other times it's just like it is today, where it's perfectly quiet.
It's amazing. We're strange creatures, we humans, because we work all these centuries to make things easier for ourselves and build electronics and machinery, and we get it all built and we want to take a walk in the woods. We don't want to see power lines and airplanes and railroad tracks and cars, and there's the call of the wild is not a misnomer. I think we're all called there from time to time. It's good for the spirit to be in a place like this, isn't it?
Oh, I think so. And when you bring students, a lot of our students come from downstate, and they come out here for the first time, and this might be as far in the woods as they've ever been. So it's a nice experience for them too.
Yeah, it really is. The whole idea is a nice experience for us, and it pleases us on Hometown Cable to be able to come up here and look into your world, you know, outside the parameters of a 26-second sound bite or video bite. It's nice to come up here and spend a couple hours and find out what Franzi is made of, and we're very pleased with what we've done so far today, Dave.
Well, that's wonderful, and it's been great having you guys out here.
Boy, this is neat. I could just sit here until next Tuesday as long as somebody would bring me a hot cup of coffee and a corned beef sandwich every now and again. You could spend a lot of time in here, as you said, just as you said before. Just, you know, open up your heart and your soul and just soak up whatever comes along, right?
Oh, it's beautiful. Yeah. And that's one of the reasons I told you I don't carry a cell phone, because I don't want people bothering me when I'm out here. So.
I know quite a few photographs have been taken, and I'm sure a lot of video has been shot up here, but hopefully the video that Calvin has shot today and the several other times we've made visits to this area in the past will also become a part of a little chronicle of history that people down the street can view and say, wow, that's the way it was.
That's what it looked like
on October 17th, 2000. It's kind of neat.
And here come our geese. You can hear them.
I can hear them too. It just, that you just set up a recorder in the lean-to. No, they're out there somewhere.
Well, that student from UVM accused me of setting up the coyote shot for her. So
well, that would have been nice to catch on video, wouldn't
that have been nice?
Ooh.
Yeah, yeah, they're very healthy here. So
I can hear them back behind us, circling around, saying, "We can't land this. Sam's over there. We got to wait till his truck leaves, huh?" All right, we've covered the waterfront here and the shores of ancient lakes and seas and rivers, and done lots of nice things. And we'll go back to where we started and add the last chapter to our program in our interview with Dr. Dave Franzi. Let me see. Can you see him? Oh, there they are. There they are in two small groups. Can't you just interpret them saying, just take a left there, right by that pine tree. We'll go over there. I think I can smell lunch. There, the geese came in, and they're settled in there for a nooner as we're recording here just after 12 o'clock on the 17th day of October, standing on a little wooden walkway that looks pretty safe, so I'm not too worried.
Oh, it's well built. It's well built.
You said that there's water leaking underneath this dam.
Yeah, right now you can practically hear the little bit of a trickle. Just be quiet for a minute. You can listen to it. So there's very little water actually going over the top of the dam. But if you look in the stream's carrying anywhere from 1 to 2 cubic feet a second. So there's actually a good flow of water coming out of here, and it's leaking underneath the dam. So try as they might to make a good seal with the bedrock, they weren't able to seal off all the leaks here. So and this is we have been here before, where the water level in the late summer has been so low that this has all been dry, that the water hasn't even made it to the dam in the past. And then certain other years, the water's flowing over the top the whole year round. So it varies quite a bit. Oh, there's that little beaver again. See that?
You can see him way down in the corner down there. You can just see his nose.
Might be a muskrat.
I'm not sure if it's a muskrat or a beaver. He's just sitting there being very quiet. I can see his nose just touching the water.
He looks more like a muskrat.
He is a muskrat, I believe.
Yeah. He's bold.
He's bold and brazen, but don't go in his territory. He'll bite your finger off. Yeah, they're busy all around here. I told you there were creatures up here, and and people like us are probably fairly few and far between. But it is. This is a geologist's dream up here, isn't it?
Oh yeah, yeah. And on the one side, some people would look at it and say, "Well, there's only one type of rock here." But there's so much more to the geological story here than just the bedrock type that's here. And I think the glacial history of this whole region is really quite fascinating. And that's of course the part of it that I like the most anyway.
It's hard for us to believe when things look very sedentary and quiet and static and stable as we stand here. But change is occurring at many levels all the time, isn't it?
It's always happening, and one of the problems that we've had in trying to figure out whether or not the burning of fossil fuels is causing global warming is that there are many other kinds of natural things that affect climate as well, and it's sorting out all of those things. They change continuously. We go from ice ages to non-glacial periods all the time, and we can see that in the geological record.
But at least we're trying to become more aware of our environment and these kinds of changes, so maybe we can predict. You know, it's like trying to predict the weather long term. You know, we think we have some of these sciences pinned down. Guess what? We're still learning a great deal.
Oh yeah, yeah, but that's some of the value of studying things like this, is you just get to know more about the environment you live in.
Well, let's move off the dam and go on to the last chapter of our program today. Now we're inside an outbuilding, which is distinguished from an outhouse by the fact there's only one hole in here. David, what is this?
Yeah, and you better not use it for that purpose.
Okay.
This is a gauging station, and what we're doing here is we're continuously monitoring the discharge in the river that's leaving Minor Dam. And basically, this device is very, very simple. You probably can't see it; it's a little bit dark in here. But this pulley right here has a float. Well, I guess first I should describe. This is a concrete manhole that's 9.5 feet deep, and it actually goes below the level of the river outside. And there's a pipe that is in the river that comes into here. So the water level that's in the bottom of this well is the same as the stream level. And we call it a stilling well because you don't get the turbulence that you get out in the stream. It's nice and quiet in here. So we have a water surface here that's the same as the water surface outside. And this device here, this pulley, has a float that is resting on the water surface and a counterweight. So as the water comes up, the pulley turns this way and it rises. And as the water level goes down, it falls in the other direction. All of that is all of those turns are being recorded on this little data logger right here. And let's see, I can pull up the screen here. Just go through the menu. So right now, the height of the river is 1.66 feet. I mean, sometimes you hear on the weather reports, they'll tell you what the river stage is or the lake stage. This is the stage of the river here. It's 1.66 feet above the bottom of the manhole. And what we have to do is I come out with the students again and we measure the river discharge using a current meter. We actually calculate how much water is flowing. And we create something called a rating curve. Can you see that all right? Okay. And this is just, it's just a graph that relates the stream discharge that we measure and the water height, which we're recording in here. So, for instance, here's an equation right here. If we know what the height of the river is, we can use that equation to then calculate what the discharge is. And this is the way that the U.S. Geological Survey does all the gauging around the Champlain Valley. If you've ever seen some of these gauging stations, they're on all the major rivers going into Lake Champlain, on the Salmon River and the Saranac and the Au Sable and Chazy. There's even a U.S. Geological Survey gauge here at the mouth of the Little Chazy River in Chazy. And so what the rating curve does then, if I can show you this graph, I just made this one this morning. This is a graph of a rainstorm that happened on the 17th of July. And the rainfall is indicated by these light gray peaks over here. So all the rain fell kind of in the afternoon of the 17th of July. And what that did, it produced an increase in the discharge of the river. And this curve right here is the Little Chazy as recorded by this gauge right here. And this one, the darker line, is the gauging station down at Chazy. So it's showing you how this rainfall caused the stream discharge to change over time. So this is discharge increasing in this direction, and that's from the 17th of July to the 22nd of July. And these are what we call hydrographs. And this really helps us, because you notice that it takes a lot longer for the river to peak downstream. So a lot of times when you hear that the flood is cresting, what they're talking about is they can predict by studying hydrographs like this when the peak discharge is going to hit different parts of the stream. And you can even predict sometimes what the magnitude of those will be. But it all comes from gathering data like you would collect at a little inobtrusive gauging station like this.
Great. Well, we've heard some of the voices from the past today as we open up our minds as David instructed us to do, and we've heard some of the sounds of today with some logging operations going on behind us. But this is a perfect spot to wrap up our program today with my heartfelt thanks for the time you spent with us, and your sage instruction has been well taken. It's really great.
Well, it's been wonderful for me too. I really enjoyed it.
Good experience with Dr. Dave Franzi from Plattsburgh State, a geologist here for a long time. This area has been here longer than Calvin and Dave and I have been, and will be here for a long time to come. But we'll update it, Lord willing, and if the creek doesn't rise, to quote an old saying, we'll be back here again. I don't know where we'll be next time, but you'll find out on our little corner.